I just want to thank everyone for coming. That is, we know how rainy and scary it's happening here due to weather conditions. I will not take too much time, so we can all hit the bars and actually, enjoy the rainy weather outside while drinking inside. So this was actually a presentation for WebAssembly part. So I'll go quickly and mention some things about Near Protocol. Quick show of hands, who actually is familiar with Near Protocol? All right, cool. Yeah, so we have a pretty interesting team which comes from a background in industry where we have built distributed systems. So me, myself, I worked on TensorFlow, on distributed machine learning at Google. My co-founder Alex and a few of our engineers worked on a sharded database called MemSQL, which is used by a lot of kind of evil corporations in the world. We also have engineers from Facebook, Consensus. Our kind of core team of engineers coming from this thing called ICM ICPC, which is international competitive programming, where you're given 5 hours, you need to solve blockchain type of problems, and you get judged by that. And we actually have a lot of kind of founder DNA. So 9 people out of 30 actually have tried to start or started a company before. So we raised really good round from really good investors around the world, as well as we are about 30 people now and still growing. So if you're interested, let us know. Now, what is actually we're building, right? There's a lot of kind of protocols trying to build a new, for example, token, trying to build a new application platform. We're really interested in kind of building something that's accessible to regular developer and is actually better than what people right now are using in Web 2. Right? So one of the kind of main focuses is on experience, making sure developer experience and end user experience is actually on par or even better than existing systems. In general, we think that this kind of platform can provide kind of new wave of innovation, right? Because at least from the things we observe right now, there's less and less new things you can build on Web 2 because big companies like Facebook, Google, they can actually build the same things, they can track what you're doing, and pretty much push to users products that are maybe subpar to something more innovative, but pretty much take over the market right away. Now, to actually achieve that, you need scalability. So we just had a great panel that was talking about how to, from our perspective, sharding or some form of parallel processing is the only way to actually get to scalability. There's Lane before was talking about that you can actually scale up one chain through some of the processing. From our perspective, one of the main kind of concerns is that unless you start scaling up hardware, and Solana, for example, is an approach like that, there's only that many transactions or that much processing you can do on one machine. Actually, even more interesting, there's been some work on Ethereum right now. If you remove all of the consensus part, they've been just trying to run sync up. So if you download all the blocks already and you're just trying to sync the state, so execute all transactions in EVM, the limiting factor end up not being processing, but actually I/O, because of just how we're organizing state in the blockchain, right? So actually right now, in this current systems, we're limited by how fast we can read data from disk, not even processing. Now, even if we optimize that and solve that problem, still there's only that much computational power we have on one machine. So the idea is over time, we need to scale up and kind of go over. And if we're targeting for kind of mass market, we're targeting for, ideally billions of users, but, let's start with millions. You do need kind of more than one machine to process your computation. So we have this design called Nightshade. The idea is, as I was mentioning before, is that instead of kind of running lots of chain in parallel and have some synchronization mechanism between them through relay chain, beacon chain, or some other way, IBC, instead you actually have one blockchain, and in a way it synchronizes everything every block. And that gives you a lot of interesting properties. One of them, this is way simpler to implement, But the other one is if there is anything that's invalid or anything that's kind of needs to be routed, this can be resolved within one block. And like if block time is relatively fast, you're now getting to kind of very similar space as when you're building for Ethereum right now. Now, like there's a lot of interesting stuff. I will recommend people to check it out. It's near.ai/Nightshade, or ask me questions later. So Lane mentioned a lot about WebAssembly. Like the benefit of WebAssembly is that it's not like our crypto community building some stuff. It's like a huge movement. There's meetups, people talking about WebAssembly outside of crypto, people who don't care about crypto at all. So there's like a huge benefit of like tapping into bigger community of like open source, of people who are excited about building something that runs everywhere. And given like what we're trying to achieve with blockchain, right, new computational platform, this seems like a perfect match for what we're trying to do. And this provides kind of a perfect platform for this. So there is a lot of like tooling that's been built. Some of it is pretty mature still, but that's kind of where we can come in with, especially around incentive structures where we have in blockchain, we can actually push through and actually build out more tooling there. And the benefit is pretty much all of this and more protocols right now pretty much converging on using this tooling, right? Space Mesh, Ethereum 2.0, Polkadot, Oasis, EOS already been launched with it. So this is not something new. This is not something that people like thinking of. This is happening right now. So now, and I think like the interesting comparison here is what Ethereum 2.0 is trying to design. They're kind of saying, well, we'll just run something, and then on top you can build any runtime environment. From our perspective, like we want to target developers who want to start building applications now, and for that we actually need to build them a substrate, pun intended, that actually allows them to build applications in a like ways that they are familiar with. So the way we think of it is that as a developer, especially coming from like web or mobile, you are familiar already with kind of Node.js or maybe Parse or some tooling like this where you have a kind of backend that maybe like is a multiple services interacting with each other, have some database attached to each, and you can interact with it from the front end, right? And we're modeling our runtime, our kind of execution environment via that. So we did a lot of customization how accounts work to kind of solve a lot of usability problems. But specifically, we provide kind of you a key value storage, like a persistent key value storage that you can access and tap into, similar if you had like a Redis database backing up your Node.js app. And now, actually, Lane was mentioning cryptography. So we are providing precompilers for cryptography because they're still slower, sadly, if we implement it naturally. But specifically, we're adding async. And this is the idea that as you build up in the sharded environments, you actually need to communicate it asynchronously, and you actually need to give these primitives to developers in a natural way such that they can build applications really easily. So just a few things to mention. When we talk about async, the idea here is that every application kind of works on its own. So like similar to a service, right? You're running a Node.js service, it's its own application, it always communicates with other services async, and it doesn't matter if it's in the same data center, around the world, on the moon, right? So same idea here, every contract or application runs kind of on its own and can call asynchronously any of the contracts. And you don't need to think if it's on the same shard and different shard. And that's what I was saying about fees. You also don't need to think about that. You kind of prepay, buy gas as you enter, and then it doesn't matter which shard it is on, the price is the same. Now, like our runtime pretty much provides a few tools. So you can create async calls, you can have callbacks, which allows you now to handle a lot of like successful failed cases. Example would be, you try to transfer token, it like was allowed to you to transfer, but it's actually not there anymore. Here you'll get like an error back and you can handle that naturally. You can have joins, so you can actually call multiple different contracts, train a hotel problem, you can call multiple contracts, see if they succeeded, handle the failures or handle the success on a join or and then pretty much decide what to do based on that. And you can do pass-throughs, which are very useful, for example, in ERC20 style contracts where you want to transfer somebody token and then let them know you actually did, right? Right now, you need to do 2 transactions. They're not atomic. It actually falls apart or can fall apart. Here, you can just say, transfer to that person and then call a function, or transfer to the contract and then call a function of that contract. So obviously, there's a lot more primitives that needs to be built, especially around locking. Actually, my co-founder was at Ethereum Denver earlier this year with a project that was resolving deadlocks without having any centralized kind of routing mechanism. So there's like ways to build primitives that actually solve some of the problems that we have as like in asynchronous environments. And we will be building them up both on, if required, on runtime, but mostly as application on top. Now, what is all this runtime is kind of what blockchain provides, but really it's all about programming environment, right? So we want to make sure that developers can kind of easily tap into this and start building. So we have 2 kind of bindings that we provide. So TypeScript is pretty much a language developed by Microsoft. It's JavaScript with types. There's a great team of engineers, very small right now, hopefully will grow, but that builds an assembly script compiler that compiles TypeScript to WebAssembly. And the benefit of it is actually it's very natural for like a web developer who has been writing front end or has been writing a full stack to start building this kind of applications. And so it integrates with NPM, it's NPM install, you have dependencies for your project, both for kind of assembly script part, smart contract part, and for front end can be done in one environment. Now, Rust has way more kind of robust setup for this because WebAssembly is built by the same people as Rust. So there's a huge benefit of them building full tool chain for compiling to WebAssembly. So we also added our kind of bindings, which are very lightweight. They're just the one macro on top of your kind of struct. And it integrates with Cargo, so you can build up your full contracts really easily in Rust, have lots of unit tests, which you should, and pretty much deploy them easily. Check it out. Now, one of the other things we did is actually kind of pulling it all together into like a tool that a developer who doesn't know anything about blockchain can kind of tap in and start trying, right? That was like one of the things for me when I started in the space, which wasn't that long ago, was like, hey, how do I even start, right? Like I need to install like all kinds of tooling, the versions were misaligned, like something didn't work. I think I sent like 2 pull requests while I was trying to set everything up. So here we have just a near.dev, which is our IDE, which you can create a new project from some templates, and you can just run it. And what it does, it compiles it and actually launches it on testnet. So you get a full app with a link, with a front end that connected to a testnet just in like 15 seconds, which is like required to load everything. And then you can go and iterate, right? You can start adding stuff and like screw around with it, or you can download and do it locally and kind of repeat the same thing. So that's the idea, right? Like like we use it as a fiddle. We actually use it as like JavaScript fiddle, where you can like show an example, send it to somebody, they can look at it. Some people like at a hackathon can actually build a full project in it because you can like share this link, other people can like plug into it and edit stuff. But that's kind of the benefit of like, hey, let's get more people into this environment. So just to kind of finish, if you want to check out and like launch your first smart contract in WebAssembly, near.dev, we have a kind of program. If you want to build a business on blockchain, we actually help a lot projects that come to us. So it's called beta program. This involves both like technical mentorship and like overtime investment. We have ambassador program if you want to kind of help out, spread the word. And we're also starting to onboard validators on our testnet, which in about a couple of weeks, we're planning to open up a incentivized testnet where the goal is to break it. So just to kind of finish up, one thing we're doing is actually producing a lot of content. And so we have this thing called Whiteboard Series. Actually, all the projects presented here were there. So we had Justin from Ethereum 2.0, we had Zaki from Cosmos, we had Alistair from Polkadot, and we had James from Suma. We have about 30 videos right now, and we're going to have more. So it's a lot like a whiteboard episode where you pretty much interview the person about the tech at the whiteboard in depth. And this is one of the greatest tech resources right now there. That's pretty much it. Any questions?
The way you develop your dApp, this project is the same as we just used with Web3 and Geth?
So the question is the way to develop applications the same as with Web3 and Geth? So here, in theory, like you can do that. You can develop in a very similar way, or you can make it like 10 times easier, where you don't need to have Geth. So here's the studio. Launch the app. So this compiles it and deploys it to testnet right now. You can go to explorer.nearprotocol.com, see the app, and then here in Studios there's a front-end code as well, and you get this. We also have a wallet and like bunch of other tooling to integrate. So here's my contract. It's not very sophisticated here. I'm just storing messages in the database, in the blockchain. A couple of functions, and there's a bunch of like boilerplate, but there's a code for a front end. And you can download this and do the same thing locally. Just say an npm deploy, and it will do the same thing, launch it. You can specify that you want to use local node, remote node, testnet, mainnet, whatever.
Is there also a CLI tool? Is there a question?
There is CLI tool, yes.
Is it like app chains versus the absolute from the simplistic perspective?
I mean, it's a different question, but is this a question?
Different by Web3. Was it a question about Polkadot?
No, the Web3.js.
Yeah.
Okay.
Yeah, so we have like alternative of Web3. It's called nearlib, which is like the kind of library to interact with the blockchain. And then, so you just use it to interact with the blockchain.
You mentioned that we are using TypeScript. This TypeScript just to compile the code?
So this TypeScript compiles into WebAssembly and is launched on the blockchain. So it's smart contract. So instead of Solidity, you use TypeScript.
Yeah.
And then you can also write TypeScript for front end.
Oh, she's talking about main.js.
Yes.
Oh, main.js. Yeah, main.js is just your front end. That's what you write. Like it can be TypeScript, can be JavaScript. But yeah, we can talk more after. Yeah.
Could you compare your sharding approach to Ethereum 2.0 approach? Because I think there was something missing during the panel.
Sure. So as of a week ago, it was pretty different. As of what was that? Day before yesterday? Yeah, it became way closer. Yeah. So like high level, kind of the approach we're taking is like pretty much simplify and make sure that we can build something performant right now. That's like on the high level. On like specific level, the sharding design for Ethereum 2.0 has been changing for the last 14 months. We have been looking at it. So it's really hard to compare because, like, for example, they just switched to kind of similar model to us to synchronize, or like they're doing it like we actually synchronizing every block and its requirement. They are trying to synchronize every block now. Like cross-link every block. So we require to cross-link every block. So if you don't cross-link, we don't make progress on shard chains. So we don't actually have shard chains. Versus Ethereum, at least right now, in the new design, still have shard chains, but they are cross-linking every block. And the idea is like you do need to cross-link every block if you want to route if you want to route and not have like price asset differences between shards. So then like we have fee market that kind of smeared across all shards, because as I was mentioning, like I don't think there's any way for developers to like manage this if the price between shards is different. We'll see if I can convince Justin on that.
So do you also have a kind of a relay chain or a beacon chain where?
So we just have one chain. So like that's what I'm saying. In our case, this is just one block, and like it's a logical construct. Like it's a logical chain with actual headers that are produced, and then shards are not really chains. They just get included into block. Like you can think of it, everybody produces a part of the block, and just nobody observes the full block. Yeah. But like in result, it gets you exactly the same properties that you pretty much have like synchronization. So you can reroute transactions between shards within one block. And you have like data availability issues solved and stuff like this. Like one of the things, like we pretty much, when shard is produced, it's actually split into parts and sent to all of the other shard producers. So they will respect only blocks that they've seen shard pieces for. Also, while you're sending this, you also send all the receipts. So they actually have them in a little bit optimistic way. They don't need to go and fetch them after they see the next block. So there's a lot of kind of like just pipelining that happens to make sure we can produce these blocks as fast as possible.
Can you also contrast the timelines for those two projects?
I'll not, comment on Ethereum 2.0 timeline, but so our like pretty much 98% of the code is there. It's on GitHub right now. There's like 20 pull requests, which should be REST 2%. We're planning to launch like incentivized testnet where everybody can participate. I encourage everybody to actually try. The idea is the more you break our system, the more you're rewarded. So like invalid blocks, collude with everybody, to like fork off a chain, long range attacks, anything you can do is greatly appreciated. The idea is to like battle test it and actually get all of the like possible security risks out the door. Kind of before mainnet. And then depending on how that goes, like plan would be to launch by end of the year or kind of January next year. Yeah.
A few more questions. Somewhere in the slides you have that about the runtime.
Yeah.
So you go to the slide of the runtime, you explained a few things which we don't do in Ethereum, for example. Mm-hmm. There was time. So could you comment on this time, random logging things?
Yeah, sure. So
exactly all the thing about the point.
Every specific thing. Yeah. So the way like runtime, like the way we coded in general our system is that it's split into two pieces. So one is runtime, which is like you can think of just a database, which receives a bunch of transactions, needs to process them, and returns you new state root. And then you have a chain which doesn't like as little as possible knows about the runtime and can do like whatever, like deal with whatever. Like one of the examples I actually took Tendermint and plugged in our runtime into that, called it Nearmint. So you can just run the same thing with Tendermint consensus. So here, this is kind of the API that like you can fetch from the blockchain. So for example, what's the current block index? Time is just a timestamp on a block. So same as Ethereum currently. There might be some ideas on like BFT time or stuff like this, but you should not rely on that. That is a not.
Okay, so basically the time is just a concept. I mean, it's not.
Yeah, it's not a time like function or anything. Yeah, it's just a timestamp from the block. Random seed. So we have a randomness kind of not a beacon, but just a like it's a run DAO with pre-commitment and erasure coded. So actually, even if you have less than 1/3 offline or trying to kind of collude to not present the data, you actually can recover their commitments. So it's unbiasable.
Do you recover that? I mean, so do you protect if somebody will deny to compute a random or
well, if it's like denied, like
resolve the random number.
If they do not commit to the number,
they will see that like I don't like it at the end of the day.
Yeah. So that is what erasure codes prevents. So if you have less than 1/3 of the kind of people who are trying to prevent, then you can recover from their commitments.
Okay.
Yeah. So near.ai/randomness is to check it out. And then so one of the cool things, and given I already have this, I'll just show, is you can for example, log stuff. So I think it's context dot log. So you can actually just, add some logging. And actually, so one thing that's cool about
I think it's logging, not logging.
oh, it's logging. Okay.
You have to actually import it because we captured that.
Yeah. Well, yeah. I'm traveling too much. So one of the cool things about WebAssembly is that it actually runs in browser. So there is nothing yet right now, but there is actually in Firefox a debugger for WebAssembly. So in theory, there can be a debugger, like a full-on debugger for smart contracts that are compatible to WebAssembly that's in your browser. So you can just debug this right here. For now, the thing we added was to allow you to kind of really easily log. So I'm coming from writing a bunch of machine learning code and in Python, so I've been used to writing prints everywhere for all my life. So, but it's definitely better than right now in Ethereum, where you just put a search and see where it fails. Yeah, so here's the log is just show up in the application, right? So you can actually build a bunch of logging in your smart contract, start writing, interacting with it, and then see what happens and kind of recover.
I'm using my node. So if I'm using a node, then I'm using a bunch of logs probably.
Well, if you're using a node, you'll see logs in the node's output, yes. Or you can disable it.
Not as a Node.js, but not as a near node.
So, I mean, here you'll not, this is not the node's logging. That's just, you will see the logging in the node's terminal.
The application will be in one shot, or your application can be in different shards?
So usually application is in one shard, but we are designing how multi-shard applications will look like. So one of the things is what we want to do is actually application be able to store data on a user account. So right now it's possible kind of through Hackery, because our kind of user accounts actually support multiple keys. So you can actually deploy deploy contracts on keys and store data under them. But going forward, we're planning to support some a game, for example, wants to store cards or kitties under the user's account instead of storing everything in one huge contract, right? So you can actually start actually sharding your contracts as well.
What will be your average DPS per chain, per shard?
So right now, with the current kind of setup, we benchmark 800 to 1,000 transactions per second per shard. But we'll have way better numbers in coming weeks as people starting to destroy our network.
Will you have a maximum limit to the number of shards that you have?
So right now, we're planning just to cap it at 100. And thing I didn't mention, we actually have a dynamic number of shards depending on the usage. So as usage grows, as more gas is spent, we actually increase number of shards and rebalance where contracts go, which also allows to solve for some of the fee problems, because now you can you cannot rely on any of those things. So when you rebalance that, we're gonna cap out at 100, I think, just for safety reasons for now. So if people start, somebody decides to spam it. But I think the limitations here are mostly on network and how much network we can push through. And it depends on what validators run. So I think we'll see as we kind of go into the stake wars through our incentivized testnet, we'll see what actually is possible.
So if I understand correctly, as a DApp developer, I don't have a choice. I mean, I'm not selecting the shard, and since the system is doing it. And then when you were talking about the asynchronous contract execution, do I get it correctly that the function call can span across different epochs, many epochs?
Among many blocks. So yeah. So you pretty much in one block you would execute a function that would call another contract, so that will create promises.
The function can finish few blocks later.
So I mean, this function will finish here, but the whole transaction can finish many blocks later. So one transaction can span multiple blocks as it processes across, jumps across shards, comes back.
Okay, because it will be always a closure, yes?
Yeah, it's all closure, yeah. And sadly right now, like TypeScript, the assembly script does not support proper closures, so you kind of need to write functions, but we're working on it.
Could you tell the difference between your sharding and the one from Tom?
From Telegram Open Network. So I did not read all 80 pages, so don't quote me on that. Their design has like a lot more complexity around kind of handling different types of shards. Like from my perspective, it looked like Polkadot with Near combined. So like you have like multiple like parachains, and each parachain can be sharded. And then they had like a lot of kind of different pieces around that, how to like handle that. But I'm not like 100% sure because I haven't actually looked at the code, like how exactly they handle some of these issues, and we haven't done whiteboard with them yet. So as soon as that happens, you'll know more, and I'll know more.
What's your solution to the storage problem? Like I saw like you have key value store, which is great, but then also you have like 1,000 transactions per shard. So people are gonna add like storage. And it's like Ethereum already has this problem, and it's repricing, making everything more expensive. And I expect you will have like that multiplied by 1,000 times now. Like how do you deal with that? You have a gas pricing fee that's a magic, or like what's your magic? Yeah, what's the cheat?
So we are doing storage rent. So for example, like how much storage, how much, I think this is like in ATA nears, like in 1 -18ths of a near. So yeah, it's storage rent, and like there's like a way to delete accounts pretty much that run out of storage. And like when you reshard, so when you reshard, it's actually like accounts for how much storage each shard takes to kind of try to balance them as well. Mostly balancing for like for gas usage, but also a little bit for storage.
The problem that Gas has right now, for example, is that just for validating a block, they need 150 to 300 milliseconds.
Mm-hmm.
And then all of their whole budget of 15 seconds, not to only validate this one, but build the next one, is really starting to make an impact. And it seems like it's gonna keep growing log n style with more and more data. So they're trying to fix, but you're gonna have like way more data this way, right? So how do you,
Why, I mean, like right now, Ethereum undercharges for storage. We actually like have like with storage rent, you're actually charging for storing data, right? And then the actually going to more data will be like split into shards. But I mean, I think your point is different. Your point is that current Merkle tree storage system in general is pretty like the access time grows like logarithmically with more storage. I think like we should just fix that problem.
So you're saying basically that your data storage per shard is probably going to stay smaller than currently the one world.
Yes, I mean at least that's the idea. Like we'll try to keep storage per shard within limits, and then if some shard becomes big, we can actually chop off some of the contracts into another shards. Like we rebalance contracts between shards, like in somewhat optimistic way, right? But we can try to balance storage as well.
And what was the thing you're replacing Merkle trees with Illia storage?
I didn't say we are replacing. I'm saying we should fix that. I'm thinking of how to do that. But like one thing you can do, you can actually have a full-on key values, like proper hash map, or like that you have like fast access, like memory mapped and everything, and then you compute Merkleized on top of it instead of accessing through Merkle every time.
Can you talk a little bit more about full stack algorithm? I mean, how much stack is needed for being in, how reproducing will work?
Yeah, so
or not delegated.
So encourage near.ai/economics. But like high level, we actually the idea is every shard has 100 validators. So the more shards, the more like 100 seats, the more shards, there are more seats. And then we run an auction depending on, so pretty much everybody like sends a staking transaction saying how many near tokens they want to stake. So we then order that and find a seed price depending on all of the people who wanted to stake, and they get pretty much a proportional to their stake divided by by price of seed, number of seeds. So it's like deterministic how many seeds you will get. So what this allows to do is, like, instead of saying 32 ether is the limit, you instead find this price depending on how many people and how much they want to stake. That's kind of the idea. And then over time, as the number of shards grow, the seed price will go down. So it will become more and more accessible to become a validator here.
Do you like pre-create the list? Or do you pre-create that seeds? Or it's like after each round or after each block?
So the previous validators who have been validating previous epoch, they automatically get rolled in.
Okay, but the list is determined before, like, I mean, every epoch?
Yeah, it's every epoch, every half a day. You kind of run this, and like, it's not really an auction, it's just like ordering list and dividing by the number.
Right, and how long one producer is producing the block?
So the idea is, that's kind of, in Nightshade, the idea is there's block producers and chunk producers, which is a shared set of like, let's say 100 nodes. And then the rest, let's say, they're hidden validators. So they run VRFs, they figure out which shards are validating, and they sign the whole block. So these 100 block producers, they just rotate and produce blocks within that epoch. And then you shuffle everyone.
Okay, so one producer is producing one block?
At a time.
At a time.
Yeah, but then, so it's like 100 nodes, but then let's say you have 8 shards. The eight of this 100 will produce shard parts, shard chunks. They'll send it to a block, then everybody rotates, yeah. All right, I suggest we all get, start heading out, get some drinks, enjoy our Saturday evening. I really appreciate everybody coming. Hope you learned something. If you have more questions, let us know. We have Telegram, Discord, or preferred. And yeah, thanks again.